Epigenetics is kind of a broad term for chemical elements that either bind to DNA or they directly, or they bind to the histone proteins that DNA wraps itself around. And when you get these elements binding, you can turn genes on and off, basically. If you get methyl, one carbon methyl groups binding to a piece of DNA, let's say in the promoter for a gene that will make you obese, you can basically turn that gene on, whereas if they didn't have the methyl groups there, you might not be able to turn it on. And that's the whole idea behind the environment causing methylation. And what I mean by that is a lot of different food groups, a lot of different micronutrients, many different compounds that you ingest, or even certain drugs that you take are what are called methylating they're compounds that will actually cause this type of epigenetics phenomenon to happen. And that's very exciting for a number of reasons. One, it shows how you're in tune with the environment and how your environment can really affect what your phenotype and how your genes are turned on and off, but it also can be passed on to later generations, which is really interesting. So it's almost like evolution happening because of what you're doing in the environment. I think one of the things that you have to be aware of is that there's about 200 different types of cells and tissues in your body, 220, and they all are epigenetically programmed differently. So so when you talk about global methylation, right, that's a very difficult thing to actually even do, because a lot of these, if you give methylating compounds, a lot of these compounds won't either get to the tissue that it needs to get to on a precision level, or it won't, even if you hypomethylated or hypermethylated everything, it doesn't make any sense in terms of what you're going to see in terms of a phenotype. But we don't have a lot of tools to kind of precisionally guide methylation down to the individual tissue level yet at this point. So it's really hard to get extremely well-targeted methyl groups down to the individual tissue. You can global methylate, and then get an effect, and it might be a good effect doing that, but it's not going to be a precision effect. What you do is you look at different compounds that methylate, like certain compounds, like, if certain polyphenols only become methylating enhancers when they bind to a certain particular gene, and that's only present in certain types of tissue or certain types of even individual cell types. So you can kind of do that on an individual compound level, but it's not quite there yet in terms of really getting it guided in the precision. But we're working on it. You've got inducers, which are compounds that put methyl groups on, or acetyl groups, or phosphate groups, or certain microRNAs, and then there's erasers. There's a whole slew of enzymes and stuff that take them off, because on a daily basis, your cell is trying to protect itself from bad things happening, and so the cell doesn't know that this methyl is a good thing or a bad thing. It just goes in there, and it's not a normal thing potentially to be on that piece of DNA, and so there are enzymes that come in and kind of clean it off, and that happens kind of automatically, right? And so what we've seen is that to get something to stick, and so you do get a phenotypic effect, it's better to give a methylating agent a low dose over a much longer period of time than to give like a big whopping dose and then a big dose 2 or 3 days later. That doesn't work, because your body by that time has erased everything or erased most of it. Even now, today, methylating compounds and epigenetics is used in cancer therapy. There's about 10 drugs that are considered epigenetic drugs and going after epigenetic pathways, and they're approved for liquid tumors and then a few solid tumors. We're going to see a lot more of that. We're going to see some natural compounds that are probably going to get approved, like curcumin or turmeric, as anti-tumor agents, and they're considered epigenetic modifiers. They go in and they either prevent enzymes from methylating, or they are erasers of methyl groups that are already there, but they do something, to affect the cell, which acts, as an anti-tumor compound. So we're going to see a lot of that. And then we're going to see, potentially for metabolic, individual metabolic diseases, whether it's, triglyceride, too much cholesterol, or, increased LDL, or, atherosclerosis, or even diabetes, too much sugar. You'll be able to see natural products, coming to the forefront of, this whole idea of medical foods. We're kind of teasing back what that actually means, and coming up with the science to back up a lot of those claims.